In our last class, what we have learned? Blood, its different components and their functions. So you have to know the functions of each component. Understood? You have to know the functions of each component. For example, there are cellular components. So you have to know the functions of RBCs, functions of WBCs, thrombocytes. Okay, similarly you have to know there are so many things in plasma. Plasma proteins, beside plasma proteins, but there are two types of components mainly. One is water. What is the percentage of water in blood? 90 to 92%. On an average it is 91%. It's good. And other than water, there is some other component. This is solid components. And these solid components are divided into organic part, inorganic part. In the organic part, there are so many things like different ions, cations, different anions. So this should have, why they are present in blood? Definitely they have some role. So you have to know the functions or role of those electrolytes. Okay? There are other organic components. Among the organic components, major component is plasma protein. Today's discussion is completely based on plasma proteins. Beside this, there are other components, other organic components like NPN and some nutritional nutrients like fatty acids, glycerol, glucose, cholesterol. So many things are present. Other organic components, NPN, non-mood protein, nitrogen. So you have to remember the word. Who can remember? What are these non-protein nitrogens? Not protein, but they are having nitrogen in this compound. And mainly they are the waste product or the metabolic end products of protein metabolism. Yes, of course. Urea, uric acid, creatine, creatinine, xanthine, hypoxanthine. So these are the NPNs. Always you have to remember. And not only this, you will be learning sequentially how this urea, from where this urea comes. From where, how this creatinine is generated and released in blood. So you have to know that. Why they are present. They are present, they have to be eliminated since they are excretory products, end products. So when they are present in my body in large amount, they are going to affect my body. Okay? So each and every component you have to know. And for that, you have to face. So what has been taught in the last class, you have to learn that by heart. Okay? Why you have to learn that? Because for future studies, not only this, you have to prepare yourself for tutorial. There will be Vaibhavusi or different form. Or you may be asked for a seminar. So you may have to provide a seminar. You have to be there in a discussion. So I have given the topic, you discuss yourself, within yourself. Okay, so you have to prepare. Unless you know the topic very well, how can you participate? So you have to know this, study this for different purpose. Internal assessment, starting from internal assessment to other exams. Okay, clear? So those who couldn't attend the class, so while you will be back from here to your, say, residence where you are staying, so you have to learn what has been taught in last class, that you have to learn. So you have to buy 2 books for Neo. What are these 2 books? Ekagene and GK Park. Right now you start with this. Okay? So you follow that book. Now, so we have seen plasma contains plasma proteins. Whatever the proteins are present in blood, they are in blood means in plasma, they are termed as plasma proteins. They are very, very important. They are serving different important functions. We will be going through that. They are also classified in different forms. Okay, and can you name one protein that is present in cellular component, say particularly in RBC? Can you name the protein present in RBC? Yes, correct. Can you name one? See, proteins are of different kinds. Simple protein, conjugated protein, derived protein. Okay, so what class this hemoglobin belong? Whether simple or conjugated or derived? It's a conjugate. Somebody said it's a conjugated. Conjugated proteins are, what are the conjugated proteins? Simple protein. When remain attached to another compound, we call it conjugated protein. So when it is attached to simple, when hemoglobin, this what is there? There is a protein called globin. So it remains attached to iron containing compound. So it can be termed as metalloprotein. It can be termed as metalloprotein. We can term it as chromoprotein. When protein remains attached to a colored substance, is a color substance. So it is giving the color of the hemoglobin. So it can be termed as chromo means color. Chromoprotein. Understood? Okay. Now the plasma proteins. We have learned this. This portion is cellular portion. We have taken this mass of blood and then we centrifuged it. As a result, a clear supernatant is found. That is the plasma part, and at the bottom there is cellular part. Okay, and in between there is a Buffy coat, and this Buffy coat contains what? WBCs, platelets, and some abnormal. If there are abnormal cells, sometimes doctors want to know whether there is any abnormal cells are there or not. So you have to take the Buffy coat and make a slide, make a smear of it, then study under microscope, and you just check whether any abnormal cells are present. Particularly when suspecting cancer, those abnormal cells are important to study. Okay, so see, this is when centrifuged a blood of anemic patient. So cellular content is less, but plasma content is more. That is hematocrit. It determines the hematocrit, PCB, packed cell volume. Okay, so PCB in anemia, PCB is reduced, not 45%. It is much less. But in polycythemia vera, where more RBC is produced in our body, but they are not normal, they are abnormal in polycythemia vera. So here see, cellular component is much higher than normal. So hematocrit is very, very high. If I ask you, can you name a condition when hematocrit is raised? The example is polycythemia vera. So in the two, you have to make clinical correlation. Those who are having more efficiency in this relating to clinical subjects, then those will be going to excel in the subjects. Okay. Composition of plasma, it is already I told in my last class. And serum and plasma. Are there any difference? Who can tell me what is the difference between serum and plasma?
Plasma minus fibrinogen and serum is plasma minus fibrinogen and plasma.
When blood is not allowed to clot, by adding, if I add anticoagulants, then it will not clot. And then if I centrifuge this blood, then they will get a clear fluid at the top. So this is plasma. So this fluid component of blood before coagulation is plasma. But if you take out certain amount of blood, so it is not adding any anticoagulant, then what will happen to it? This will be coagulated. A clot will be formed, okay, into a semi-solid jelly-like structure. And if you keep this for certain time, then what happens? The clot retracts. As a result of retraction, some fluid comes out of this clot, and this is serum. So, what is the difference between plasma and serum? Other than this is the technique by which we get plasma and serum. But regarding composition, there must be some components have been used from plasma into the clot formation. So, since these components are engaged in clotting, they are within the clot. So, they will be absent in serum. So, what are these? The proteins which are needed for coagulation. Like fibrinogen. Important is fibrinogen. Prothrombin. It has been used. Beside, blood has got, plasma has got different coagulation factors. We will be learning all these factors, how they facilitate coagulation process by cascade or waterfall mechanisms. Okay, so one after another sequence of events takes place. So, you understood the difference between and some color difference is also there. What is yellowish color? This is straw color. Serum is straw color. And one more question. Biochemical, some laboratory values, biochemistry, blood biochemistry values are given in not in terms of 100 ml of plasma, but in terms of serum. Serum concentration of calcium. So why not plasma? Why calcium? This question you will be answering in your next way. I will give some questions you will be solving and tell me in my lecture. This is one of the parts. Why we choose, in most of the cases, we choose plasma, we choose serum, not plasma. Plasma is stored as FFP, phase frozen plasma. This is required. It has got clinical applications. You will be learning. If when the topic will be coming, then I will be asking what is the use of FFP. How FFP can help us. Okay? See, serum is used in various biochemical investigation and as a supplement to cell culture and media. So, before clot, and this is serum we get after clot. What is that? You have to learn, memorize the normal concentrations of so many of plasma proteins and different components. So, I will be giving here, so you have to learn it always. So that you can say, this value is not normal. It is over normal, under normal. Okay, so that's for that purpose. Here we are here to know the normalcy, normal functioning, normal values. So unless we know the normal values, how can you study the abnormality? If you don't know the normal structure, anatomical structure of thyroid gland, so how can you assess the goiter? Because the anatomy will be changed. So what was the normal anatomy? How it has been changed? You are comparing it with the normal values. So you have to know the basic things, basic subjects. Okay, understood? So normal plasma protein concentration actually varies 6 to 8 milligram or gram? Gram, always remember. Sometimes when we ask questions, you become confused. What to say? Milligram or gram? So it is always gram. And when these values, normal values, see somebody's blood contains 9 gram percent, 10 gram percent of plasma protein. It may happen. We will discuss at the end of this lecture. It may happen. So in which case this may happen? This is called hyperproteinemia. Emia means blood. Hyperproteinemia, that is, values would be more than 8. In hypoproteinemia, what will happen? Hypoproteinemia, you have to correlate. Always, you have to correlate. Okay? So, if you know the normalcy, then you will be able to find out whether a particular findings is normal or abnormal. So, plasma proteins are 3 types. How many types? You know it very well. What are these? Albumin, globulin, and fibrinogen. In some other books, you will get also another protein, prothrombin. So you can add prothrombin also, very important. This plasma protein is also very important. And what is the normal value of albumin? Remember this, write this, 4 to 5.5 gram percent, globulin 1.5 to 3 gram percent, and fibrinogen 0.3%. It happens in our body. Sometimes fibrinogen content is raised. It may affect your body. It may produce some effects. When it is less than this, it may produce some effects. That's during hypofibrinogenemia. So there may be some problems. Similarly, when it is raised, it may create some problems. Everything. Globulin, some conditions, some pathological condition, it is raised. When your body is infected, then it is raised to protect your body. Okay, it is raised. And for some other purpose, globulin not only protecting, it is also acts as transporter. It transports so many things. We'll be learning. And so these are the normal values. I'll ask you during tutorial, what are the normal values? And the origin. You take out your syllabi. Other day I told you how to get this, what are the contents, find out the contents of plasma protein, what you have to study from there. Find out, open your mobile. Those who are new, you can get it, the syllabus of physiology, syllabus of anatomy, syllabus of biochemistry from online resources. You have to write and Google CBME 2024. That will do. NMC, another you can put NMC. So CBME 2024 and then NMC. If you enter it, then you will get a document, and at a particular number of pages, I forgot at what number of pages, you will get the syllabus. Not now. This will take time to find out the syllabus, content of the physiology. So there, what is written? What is the syllabus of plasma protein? Different forms. Then different variations, functions, and this part is always very important. clinical implications. So for relating these with different diseases, different conditions, this part is very important. Understood? So not only knowing, this will not do the purpose. These are the forms, this is the origin of plasma proteins, and these are the functions. But you have to, all this you have to correlate with clinical findings. Okay? So this is the main emphasis given in CBME. There is one program in your curriculum, that is, you will be exposed early clinical exposure. Today, I think today is there, one class is there. This early clinical exposure is based on whatever you learned in the class and whatever you are seeing in the ECE class, whether this has any relation with the theory, with the subject, basic subjects, either what I learned. So there should be, ECE should be related to the subjects, to the topics you have already learned. This should be there. So I don't know what is edema. So in the ECE curriculum, I am presenting one edema patient, but you don't know how edema is formed. What is the reasons of edema? So before that, theoretically, I had to explain what is edema, why it is being formed. So then only you will be able to correlate it, what has been showing, what you are observing, what you have to analyze, critically analyze, whether it has got some relation either with biochemistry, maybe while you will be doing a biochemistry ECE, then it may be some relation with biochemistry. While anatomy will be class will be there on ECE, they will try to correlate it with anatomical structure and this thing. Okay, so in that way you have to correlate. This is important. So this is why this is. I will explain. Not now. Otherwise I will miss the time. So origin we'll study. The origin actually starts from when we are at embryonic stage. So we know embryo is formed 3 layers. What are these 3 layers? Ectoderm, endoderm and mesoderm. So it is the endoderm, যার মধ্যে mesenchymal cells থাকে, which contain mesenchymal cells. These mesenchymal cells are responsible for plasma protein synthesis in the embryonic life. Okay, so what is in embryonic life? What are the source? Mesenchymal cells. How they produce this? Through secretion, they produce some secretion, or the dissolution. Through the process of dissolution, some components are dissolved, disintegrated. Then it is liberated in the vascular system. So in that way, we get plasma protein in embryonic life. Okay, next part. In adults, main origin is liver. Main origin, particularly of albumin. Somebody's liver is damaging or already been damaged. Cirrhosis of liver. Hypoproteinemia is the consequence. Okay. Is the consequence. If liver get damaged, liver cells are damaged and replaced by some other cells which are not having any function. It happens once damage in cirrhosis of liver is shrinked and their hepatocytes are changed. So gradually, it is done gradually. So in such cases, the liver will not produce plasma protein. So there will be hyperprotein. In that way, you have to correlate. So you have to know where these are synthesized. Albumin, this is synthesized in liver. So definitely, if liver is damaged, or if any disease is there in liver, then it is going to affect my plasma protein concentration. This plasma fibrinogen, it is also produced in liver. So in blood, I will not get sufficient amount of fibrinogen. So same, this is prothrombin. This is produced in liver with the help of vitamin K. We know what is the function of vitamin K. Synthesis of prothrombin. So sufficient prothrombin will not be produced in liver. So we will face the consequence. These patients will face the consequences. Okay. So liver is the main site of production of what? Albumin, fibrinogen and prothrombin. And what about globulin? Globulin, some globulins are produced in liver, some are in spleen. How many spleens we have? One pair, 1, 4, 1. Are you sure? Yes, you are correct. It is 1. Which side? Yes. Which side? And now the globulins, this, the spleen, they also can synthesize globulins. Spleen performs the protective function, which protects us from various diseases. Okay, because say they produce something. Say also spleen can also produce lymphocyte and antibodies. Since lymphocyte is produced, they also contain some plasma cells. These plasma cells produce different antibodies. Okay, antibodies, immunoglobulin, gamma globulin are same. Gamma globulins are termed as immunoglobulins. The immunoglobulins are nothing but antibodies. So where they are produced? Tissue macrophage of the RE system. So this macrophage you will get, and they are termed according to the organ. The macrophage, if you take the bone marrow, you will find the largest cell is macrophage. And you may also find the macrophage in liver. In liver, there are lobules, no? At the center, what is there? Central canal. Central vein. And this central vein contains some macrophages, and these are called Kupffer cells. Why they are here? Why they are here? Why not to some other place? Because you have taken food. You have taken food. Along with this food, you may also ingest some bacteria where so many germs. So what you are doing? You will be digesting the foods and you will be absorbing. During absorption, those germs can enter in your body. And through some portal system coming from spleen or intestine, this portal system will drain the blood first into the liver. And when this blood will be circulating through liver, this macrophage is there to trap you. Trap the pathogens. Okay, to trap the pathogens and kill it. Okay, so in that way, this cells also prevents us from affecting by various pathogens or bacteria or viruses. Plasma cells are produced in lymph glands bone marrow, since the bone marrow contains different type of cells, myeloid cells. Myeloid cells, they also can also produce globulins. Myeloma is one type of cancer. One type of cancer. There is some variations of myeloma, different kinds of myeloma, so that will be discussed later. And the liver, beside albumin, fibrinogen, prothrombin, liver can also produce alpha and beta globulins, not gamma globulins. These are synthesized by the lymphatic organs, okay, by the small lymphocytes. In blood, you will get small lymphocytes as too. So lymphocytes are the mainly source of alpha and beta gamma globulins. So albumin, plasma protein. So we will be studying the different types of plasma proteins. One is pre-albumin. In some books you won't get. It is combined with albumin. This is the precursor of albumin. Precursor of albumin. So when this is produced, something is added to it, pre-albumin. So then it will be converted into albumin. Okay. So see, the molecular weight of pre-albumin is 60, whereas the molecular weight of albumin is 66. Important. You have to know the molecular weight. It has got importance. Higher the molecular weight, that is higher the size of the molecule. And those molecules which are higher and whose surfaces are irregular, they have some role. And those who are having small and having smooth outer surface, so they have also, like albumin. Albumin is not like that, it's like that. But fibrinogen and globulin, the size is more, so you will find their molecular weight is much more than albumin. Okay, so since their molecular weight is higher than albumin, they will exert some other actions, which albumin cannot, or it will produce minimal effects. Okay, but one of the functions of plasma protein is generation of osmotic pressure. Very important, I will tell you. So how it is important, this osmotic pressure. So if there is any variation in your osmotic pressure, your body structure, your face, your body, superficially you can notice a change has been taken place because of change in osmotic. You will evaluate. So albumin is, molecular weight is 66,000, and among all plasma proteins, albumin is of 55%. So albumin is most abundant among the plasma proteins. It is the most abundant. Okay. So number of molecules will be more, and this is important since its content is much higher. So its number of molecules, because so many things will determine by the number of molecules present in the plasma or present in blood. I will explain. Okay. So the main function of albumin is the half-life of, see, whether these plasma proteins that we are getting in our plasma, whether these are permanent. Are they going to stay permanently? No. After some days, 7 to 20 days, depending on the type of plasma proteins, their life is half-life. Half-life is 7 to 20 days. Here, the albumin has got half-life of, see, pre-albumin has a half-life of 2 to 4 days. Whereas in case of albumin, what is the half-life? 20 days. Means, what does it mean, half-life? Means, when produced, there were 10 gram. Today, some albumin is produced. Okay, how can you say today how much is done? By tagging with radioactive material, we can tag which are produced today. Okay, so it can be tagged. So by this way, we can determine the amount of albumin produced today. Okay, so suppose this is 8 gram, or say 6 gram, and this 6 gram will become 3 gram in 20 days. So 20 days is the half-life. Later half will be destroyed later on. It will take much longer time. But half-life, usually we determine how long a substance will remain in the blood. It will be determined by half-life. So pre-albumin has a very less half-life. So you got the idea, no? Half-life. What is meant by half-life? So with that we will know how long it is going to stay in the circulation. So main function of albumin is what? A. Creates and controls colloidal osmotic pressure. Very important. I will explain when I will be explaining in detail the functions. Next is what? It binds with something and transports from one place of body to another place. For example, iron. Iron is carried from intestine to liver. From liver, it is sent to the bone marrows. So for this transportation, they will require plasma protein. They will take the help of albumin. So in that way, albumin binds and transport what? Free fatty acids. Where is the source of free fatty acid in the blood? How can you get free fatty acid in the blood? How can you get? You can get free fatty acid in the blood from two sources. The fat you are ingesting, so it will be digested in the intestine. Digested, when it is digested, say for example triglycerides. So this is, in other class I probably explained, it is actually triglycerol, and some fatty acids are attached. 3 fatty acids can remain attached to the glycerol through ester bondage. Okay, so this glycerol, this triglyceride, fatty acids, so when this will be digested in the alimentary canal, so that initially they will liberate one fatty acid and produce two monoglycerides, then another fatty acid will be liberated, then it will be from monoglyceride, then if the last one is removed, then glycerol and fatty acid. So ultimately we get fatty acid and glycerol. Now they will be absorbed from the intestinal lumen into the blood. So fatty acids are there coming through our digestion. Another process of coming free fatty acids. What is that? You are heavy, obese person. So determined to lose your weight. What you are going to do? Vigorous exercise and curtailing your daily diets. This is the option. What else you can do? So as a result, what will happen? The fats, lipids that are stored in my adipose tissue, those fatty acids ultimately will go to, these carriers will go to adipose tissue. There it will be again converted into triglycerides. Okay, so they will be depositing in our adipose tissue. When I am in crisis or I want to break down this fat, what will I do? Again, by the lipase enzyme, I will break down this lipid. This lipid stored in adipose tissue into again glycerol and fatty acid. Now this fatty acid will enter into the blood, and this fatty acid will be taken to the muscles. Muscle will utilize this fatty acid as energy source. They will oxidize this fatty acid by the process of metabolic path. What is the metabolic path where fatty acids are oxidized? Metabolic path where fatty acids are metabolized to give us energy. Beta oxidation. Forgot. Beta oxidation. Can you recall? Now you can recall. So this will undergo beta oxidation and produce sufficient energy. With this energy will be performing exercise. So in that way, you can utilize your stored fat. And in blood, free fatty acid can come from food, digested food, and also from breakdown of stored fat. So these are the sources of fatty acid. In that way, the way I explain, you have to know with your inquisitive mind from where they came, what is the origin, how they came, how they are metabolized. So you have to know that. There is self-directed learning. So everything is not possible to explain and may not be available in the books. So from here some knowledge, from here some knowledge from there. So accumulate your knowledge, then you will be able to explain. So fatty acid, bilirubin. What is the source of bilirubin? I think I have to take 2 classes for this purpose. Huh? Since I find you're in a blank state, you cannot respond because of lack of knowledge what you should have. So for that purpose, here with this this sort of lacking will not do. So you have to study again those things. So bilirubin source is RBC. RBC has got a life. After that, it will die. And it will be broken down by spleen. Any dead cell present in blood will be captured by the spleen and they will disintegrate it. And so if RBC is taken up, dead RBC is taken up by the spleen, so what will do? Spleen will destroy it and it will keep the heme part and iron, it will liberate iron on the part, colored part. Colored part, that is the source of bilirubin. That is the source of bilirubin. So this will be liberated into the blood and it cannot travel alone. So it has to bind with albumin, and with the help of this albumin, this bilirubin will be coming to liver and will be secreted through the bile. Oh, this is the one secretion, one function of the liver to produce bile. So in the bile, we will get bilirubin as one of the constituents. So before coming, so this may be when the liver cells are damaged. So bilirubin will also be released in blood. So blood concentration will rise. So with that bilirubin concentration raised. What does it mean? It means something wrong in liver. Liver cells are the origin. So they are damaged. They are getting damaged. So from the damaged cells, this is coming out. Some enzymes you will find in plasma. These are some enzymes of the liver cell. When these are damaged, these enzymes are coming into the plasma. So what are these enzymes? You have heard. SGPT, SGUT, alkaline phosphatase, lactate dehydrogenase. So these are the enzymes. These are actually the enzymes of liver. Some enzymes may come from damage of the cardiac muscle. When there is infarction, these cells are damaged. So these enzymes from the cardiac cells will be released into the blood. So when we get the say CPK or say some marker is there, which is actually is present in myocardium. So if these are not supposed to get in blood, but if I get it therein, we think there is something wrong in my heart. It is some part is damaged. So it damaged in case of myocardial infarction. So in that way you have to relate. Steroid hormones. Can you name the steroid hormones? Yes, of course. Tell. Huh? Testosterone, estrogen, progesterone, glucocorticoids, mineralocorticoids, sex corticoids. These are all steroid hormones. So these steroid hormones are actually carried by, transported, they cannot be transported freely. Good. Some drugs. You know, we are taking a lot of drugs when we are infected, we take drugs. So these drugs are metabolized in the body. And this drug is carried by the albumin. It should be carried. It cannot be transported alone. So they bind to these drug bands and go to the target cells and produce where it is released. Always these are loose bond. So they are released and the drugs can now start its action. So this is about, see, if I know the functions of albumin separately, if I know the function of fibrinogen separately, if I know the functions of each fraction of globulins, then we will be knowing the functions of plasma proteins. So you have to know individually the functions of all the components. So you have to know the functions of all the components. Okay. So when you will be studying, you have to know the component. Why this component is there? Definitely it has some functions. So what are these functions? So note it down. Second function is any protein present in blood, either in RBC or in plasma, either in RBC or in plasma, either it is albumin or it is globulin or it is fibrinogen, they will perform one particular functions also. And this is buffering action. So there is no board. So what I will do? Buffering action. How the proteins buffers excess acids. You can take excess acid through your food. You can take acetylcholine base through your food, or my tissue, or my muscles. They can produce alkaline substance, also can be acidic substance, and they will be liberate. Suppose I have started exercise. So as a result of vigorous exercise, my muscles will produce lactic acid. So they will be liberated into the blood. Since this is an acid, so it will produce acidosis. Means it will add some lactic acid. There is some carboxylic. There is a carboxylic group. Some in the COOH group, this hydrogen can be liberated. Means it can produce acid. Liberation of hydrogen means key. It will be acidic. It is adding acid. So what will happen? Body will try to. Initially it will not allow any change in my pH. So I have to neutralize this excess hydrogen ion coming from whatever the source is, either from the tissue or from indigenous or digestive through as a result of digestion. So what to do? These proteins made up of what? Amino acids. Okay. Suppose these are the amino acids. They will form a protein. Amino acid. Now, when you join together, you will form a peptide. Okay, and your one hand is amino group, another hand is carboxylic group. So this is his carboxylic group, and this is his amino group, and this is her carboxylic group, and this carboxylic amino group will form a peptide bond. So now they are linked. So this amino group, this carboxylic group will form another bond. In this way, it will produce a simple peptide. So we can see this hand is not utilized. This is free. And what is this group? amino group. And that part he is also having one end free. What is that? Carboxylic group. So this group can release hydrogen ion. She can accept, that group can accept the hydrogen ion. So with this capacity of the amino acid, they can neutralize. If you add hydrogen ion, she will accept. If there is any deficiency of hydrogen ion, he will release. So what will happen? The peace will not be altered. So this is how the plasma proteins buffers, shows its buffering action. Understood? It is clear to you? Any doubt? No, fine. So all the plasma proteins like hemoglobin, HSB negative, HSB and HB negative. So these are the buffer. Two components should be there. So these are the two components. So these two components can buffer peace. Next part is nutritive function. You do what you have decided. From today I will not eat anything. I will fast. I will go for fasting. So there is no input of protein. And the plasma protein has got certain life. And they will be destroyed. And what will happen then to the plasma proteins? So I have to restore it. From where? How to restore it? I need the amino acids. In the liver, I have to supply the amino acids with which it will produce these plasma proteins. Okay? So these, not only these, sometimes the other proteins, labile proteins, we have got in our body three types of proteins. Some are, among them some are labile proteins. Means they can be shifted from one place to other for other functions. When this protein is required for energy, so they will provide. And some other protein, say plasma proteins. If I need energy now, there is no storage of carbohydrate, there is no storage, glycogen, no storage of fat. So what to do? So I will start using protein. So I will be taking first protein from the plasma. So because of utilization of proteins for generating energy, so there will be depletion of plasma proteins. So in that way, it can function nutritive function. Understood? Next is important. Viscosity. You must have, because there are so many diseases where viscosity, because of changing viscosity. So you have to learn what is viscosity. Viscosity is rendered by big size molecules and those who are having rough surface. Why? They are responsible. They will produce more friction with the walls of blood vessels. Not the fine, say, whose molecular weight is large? Fibrinogen and prothrombin. So they will produce more friction, means more resistance, means low flow. Resistance, this will create peripheral resistance, obstruct the flow. So supply of blood to that region will be reduced. And since blood is not going slowly, cannot passing through, so in this vessel there will be increased pressure. So it will raise the blood pressure also. So that's why viscosity is very important. Viscosity means while traveling through a vessel, any fluid, we will exert pressure, we will exert frictional pressure. not the hydrostatic pressure, frictional pressure. Okay.